For electrical design in industrial machinery, several books and resources offer comprehensive guidance. Firstly, consider Electrical Design for Industrial Machinery by Stephen C. Croft. This book likely covers fundamental design principles and practices specific to industrial applications. Secondly, Electrical Installation in Buildings by Fred C. Hartwell can provide valuable insights into the installation aspects of electrical systems within industrial facilities. Thirdly, Industrial Electrical Design and Application by John J. Liptak offers a focused approach to industrial electrical design. Fourthly, The Handbook of Electrical Engineering by Alan L. Sheldrick serves as a broad reference guide for various electrical engineering topics. Fifthly, Applied Industrial Electricity by Neville Hughes could provide practical knowledge related to industrial electrical systems. Sixthly, Electric Motors and Drives by Austin Hughes may offer a deep understanding of motor control and drive systems. Seventhly, Practical Electrical Network Automation by Peter Roger could provide insights into the automation of electrical networks. Eighthly, Industrial Automation and Process Control by M. Sami Fadali covers a broad range of automation and process control topics that are relevant to electrical design. Ninthly, Electrical Safety for Industrial Applications by R. Scott Stultz emphasizes the critical aspects of electrical safety in industrial environments. Tenthly, PLC Troubleshooting and Maintenance for Industrial Automation by Michael Smith focuses on programmable logic controllers, which are essential for industrial automation. In terms of resources, firstly, the IE Explorer Digital Library offers access to a vast collection of technical papers, standards, and conference proceedings related to electrical engineering. Secondly, the National Electrical Code, accessible at, provides the standards for safe electrical installations. Understanding and adhering to the NEC is crucial for ensuring electrical safety. Thirdly, the Electrical Apparatus Service Association provides resources and information related to the maintenance and repair of electrical equipment. Fourthly, the Institute of Electrical and Electronics Engineers is a professional organization for electrical engineers offering networking opportunities, standards development, and publications. Fifthly, the Instrument Society of America focuses on instrumentation and control systems, which are integral to industrial processes. Sixthly, the Occupational Safety and Health Administration provides regulations and guidance for workplace safety, including electrical safety. Seventhly, Underwriters Laboratories is a safety certification organization that tests and certifies electrical products and systems. Eighthly, the National Fire Protection Association develops codes and standards related to fire safety, including the National Electrical Code. Ninthly, Machine Design Magazine offers articles and resources related to machine design, including electrical components and systems. Tenthly, Engineering 360 offers a broad range of engineering information, including product specifications, supplier directories, and technical articles. When selecting books and resources, consider the specific area of industrial machinery electrical design you are interested in. For example, if you are working with motor control systems, focus on books and resources that cover motor theory, control methods, and drive technologies. If you are involved in designing electrical panels, study relevant standards, wiring practices, and component selection guidelines. Furthermore, it is essential to stay updated with the latest industry standards and regulations. Regularly review the National Electrical Code, OSHA regulations, and other applicable standards to ensure that your designs comply with current requirements. Consider joining professional organizations like IEE and IS8 to network with other electrical engineers and access technical resources. Additionally, utilize online resources such as IEE Explorer Digital Library and Engineering 360 to find research papers, technical articles, and product information. Remember that electrical design for industrial machinery requires a strong understanding of electrical principles, safety standards, and industry best practices. By utilizing the recommended books and resources, electrical engineers can enhance their knowledge and skills in this field. Always prioritize safety when designing electrical systems for industrial machinery. Implement appropriate safety measures such as overcurrent protection, grounding, and isolation to prevent electrical hazards. Conduct thorough risk assessments to identify potential hazards and implement appropriate control measures. Provide clear and concise documentation for all electrical designs. Documentation should include drawings, schematics, wiring diagrams, and component specifications. Ensure that all documentation is readily accessible to maintenance personnel. Regularly inspect and maintain electrical systems to ensure that they are in good working condition. Implement a preventative maintenance program to identify and address potential problems before they lead to equipment failure or safety hazards. Electrical design calculations are essential for ensuring the safety and reliability of electrical systems. Calculate conductor ampacity, voltage drop, short circuit current, and other parameters to ensure that the system meets applicable standards. Use appropriate software tools to perform electrical design calculations accurately and efficiently. Proper grounding is crucial for protecting personnel and equipment from electrical hazards. Ensure that all electrical equipment is properly grounded in accordance with applicable standards. Use appropriate grounding techniques to minimize ground impedance and prevent ground loops. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. Select overcurrent protection devices with appropriate ratings to protect the circuit conductors and equipment. Coordinate overcurrent protection devices to ensure that the circuit is properly protected. Surge protection devices are used to protect electrical equipment from voltage surges caused by lightning or switching transients. Install surge protection devices at appropriate locations in the electrical system to protect sensitive equipment. Select surge protection devices with appropriate ratings to withstand the expected surge currents. When selecting electrical components, consider the environmental conditions in which they will be used. Select components that are rated for the appropriate temperature, humidity, and vibration levels. Use enclosures to protect electrical components from dust, moisture, and other contaminants. Electrical systems should be designed to minimize energy consumption. Use energy-efficient lighting, motors, and other equipment. Implement control systems to optimize energy usage. Conduct energy audits to identify opportunities for energy savings. Proper cable management is essential for ensuring the reliability and maintainability of electrical systems. Use cable trays, conduits, and other cable management devices to organize and protect cables. Label cables clearly to facilitate troubleshooting and maintenance. The electrical panel should be designed to provide adequate space for components and wiring. Arrange components in a logical and organized manner to facilitate troubleshooting and maintenance. Use proper wiring techniques to ensure that connections are secure and reliable. Control systems are used to automate industrial processes. Select appropriate control systems based on the specific requirements of the process. Program control systems to optimize performance and efficiency. Regularly monitor and maintain control systems to ensure that they are functioning properly. Human-machine interfaces provide operators with a means to monitor and control industrial processes. Design human-machine interfaces to be user-friendly and intuitive. Provide operators with clear and concise information. Implement alarm systems to alert operators to abnormal conditions. Communication networks are used to connect various components of an industrial automation system. Select appropriate communication networks based on the specific requirements of the application. Ensure that the communication network is reliable and secure. Regularly monitor and maintain the communication network to ensure that it is functioning properly. Electrical safety training is essential for all personnel who work with electrical equipment. Provide employees with comprehensive training on electrical safety procedures. Ensure that employees are qualified to perform the tasks that they are assigned. Regularly review and update electrical safety procedures. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Implement lockout/tagout procedures in accordance with applicable standards. Ensure that all employees are trained on lockout/tagout procedures. Personal protective equipment is used to protect employees from electrical hazards. Provide employees with appropriate personal protective equipment such as gloves, safety glasses, and arc-rated clothing. Ensure that employees are properly trained on the use of personal protective equipment. Arc flash studies are used to assess the potential hazards of arc flash events. Conduct arc flash studies to determine the incident energy levels at various locations in the electrical system. Use the results of arc flash studies to select appropriate personal protective equipment and implement other safety measures. Electrical inspections are used to identify potential electrical hazards and ensure that electrical systems are in compliance with applicable standards. Conduct regular electrical inspections to identify and correct any deficiencies. Use qualified electrical inspectors to perform electrical inspections. Electrical maintenance is essential for ensuring the reliability and safety of electrical systems. Implement a preventative maintenance program to identify and address potential problems before they lead to equipment failure or safety hazards. Use qualified electrical technicians to perform electrical maintenance. Troubleshooting electrical problems requires a systematic approach. Start by gathering information about the problem. Use appropriate test equipment to diagnose the problem. Follow a logical process to isolate the source of the problem. Repair electrical problems in accordance with applicable standards. Use qualified electrical technicians to repair electrical problems. Electrical system upgrades may be necessary to improve performance, increase capacity, or comply with new standards. Plan electrical system upgrades carefully. Select appropriate equipment and materials. Ensure that the upgrade is performed in accordance with applicable standards. Electrical system decommissioning may be necessary when equipment is no longer needed or when a facility is being shut down. Plan electrical system decommissioning carefully. Disconnect and remove equipment safely. Dispose of equipment and materials properly. Remember to always consult with qualified electrical engineers and technicians for specific electrical design and installation projects. This information is intended for general guidance only and should not be considered a substitute for professional advice. Always adhere to applicable codes, standards, and regulations.